Can you give your brief introduction one by one? One by one, can you please tell your name?
Sir, hello. I'm Thubi from Maitri, Delhi University in second year.
Okay, okay. Then next.
Hello.
Yes.
Hello, sir. I'm Anju JP.
Yes.
I'm from Kerala. I completed my BSc Physics this year.
Okay, okay. From where?
I'm from Kerala.
Okay, very good. Next.
Hello, sir.
Hello.
I am Anushka Misra. I'm from West Bengal.
Okay.
And I'm in third year.
Okay. I am also from West Bengal. Okay. From where you are doing that graduation?
I'm from KNU University.
Okay. Next.
Hello, sir.
Hello.
Sir, I'm Prajwal from Karnataka. Last year BSc passed out.
Okay, okay. Next. So myself Mukaddar SK. So I'll teach you that modern physics, part of modern physics, basically atomic physics and nuclear physics. Okay. So if you see the syllabus, we have STR. STR means special theory of relativity. That we will teach by Atul sir. Okay. Then you have wave particle duality. That also will teach by Atul sir. Then you have part of quantum mechanics. That will teach by Atul sir. Then you have atomic physics. That I will teach you. My name is Mukaddar SK. Then you have nuclear physics. Okay, that also I will teach you. Okay, so today we'll discuss that atomic physics, part of atomic physics, basically Bohr model. Okay, so if you see that syllabus of atomic physics, so if you see that syllabus of atomic physics, you have Bohr's model for hydrogen atom. For hydrogen atom, what we'll discuss? We'll discuss about that radius. We'll see that radius of electronic orbit as a function of principal quantum number. So n means principal quantum number. Also, we'll see that orbit are discrete in nature. They are widely separated. Also, we'll find that expression for speed of electron. That also be the function of principal quantum number. Then we'll derive the energy expression for nth state or nth orbit of electron. This is the total energy. This is the speed of electron at nth orbit. This is the radius of electron at nth orbit. So we will see that all this quantity are dependent on principal quantum number, that is small n. Okay. So this is for Bohr model for hydrogen atom. Similarly, same thing we'll see for hydrogen-like atoms. Hydrogen-like atoms. For example, can anyone hydrogen-like atoms? Example. What is the example of hydrogen-like atom? Anyone? So hydrogen-like atom will be helium plus, then lithium double plus or 2 plus, then you have beryllium 3 plus, etc. Why they are hydrogen-like atom? Because if you see helium plus, it will have how many electron? Helium plus, how many electron will be
1.
on, right? So it is similar like hydrogen, right? In hydrogen atom also you will have how many electron? 1 electron, right? Is not it? Everybody agreed?
Yes, sir.
For helium plus, helium has 2 electron, but plus means 1 electron is removed. So it will have 1 electron. That's why it is hydrogen-like atom, because hydrogen has how many electron? 1 electron, right? So helium plus will have 1 electron. That's why it is hydrogen-like atom. Similarly, lithium 2 plus. Lithium has 3 electron, but 2 plus means 2 electron is removed. So it will have 1 electron. So that's why it is hydrogen-like atom. Similarly, beryllium 3 plus, it will also have how many electron? 1 electron. Okay. So we'll derive that expression for hydrogen-like atom for radius of nth orbit, then speed of nth orbit of electron, energy. Then what we'll do? Third point will be spectral line. Anyone heard that name? Spectral line? Anyone? Spectral line? Everybody heard, right? Lyman series, Balmer series, Paschen series, Brackett series, Pound series, Humphreys series. Everybody learned, right? Is not it?
Yes, sir.
Yes, sir.
Did you get any problem in the class? If you have any problem now, just ask me freely. Okay, no problem. So this is known as spectral line. So third point will be, we'll learn about that spectral line. Okay. Then we'll solve few problem on this. Oh, sorry. Finally, what we'll do, we'll learn about that production of X-ray. Okay, there are 2 types of X-ray. One is characteristic X-ray and another is continuous X-ray. So we'll learn details about that X-ray. Okay, so today we'll start with that assumption or Bohr model. Anyone? Can you please tell me that assumption of Bohr model? So heading will be assumption of Bohr model. Anyone? Did you people understood now what I'm saying? Everybody? Are you enjoying class? Any problem in the class?
No, sir.
No, sir.
So I asked that what is the assumption of Bohr model? Any did you remember? So first assumption is electron rotating or revolving around that nucleus in a fixed orbit. Fixed orbit means that electronics orbit is stable. So if you have, suppose you have, this is your nucleus. So electron is revolving around that nucleus suppose this is your nucleus, an electron revolving around this nucleus in a circular orbit, and that orbit is stable. So first assumption is that electronic orbital is stable and that is circular in nature. Please write it. So electron revolving around that nucleus, that orbit is stable and circular in nature. Every people understood what I'm saying? First assumption is electron revolving around that nucleus, that orbit is stable and circular in nature. Any problem? समझ में आ रहा है? Every people understood what I'm saying?
Yes, sir.
What I said?
Yes, sir.
That electron is revolving around that nucleus, so that orbit will be stable and that orbit is circular in nature. Okay. If you will written that.
Yes, sir.
Written. Shall I proceed? So electronic orbit is stable and circular in nature. Okay. Sorry. Next, when it will rotate, it will have some orbital angular momentum, right? Suppose, let us assume the rest mass of this electron is small m, and its speed is v, and its radius is small r. Then it will have some angular momentum, right? Electron is revolving around that circular orbit. It will have some angular momentum, right? Is not it? Did you people get what I'm saying?
Yes, sir.
When it is revolving around that circular orbit, it will have some angular momentum. And if the mass of this electron is me, if its speed is v and radius of this orbit is r, then that angular momentum will be how much? Anyone? So simply it will be me v into r, right? Is not it? That angular momentum will be how much? Me, mass of electron, if its speed into radius. If people got what I'm saying?
Yes, sir.
Everybody, is there any doubt in the class? Is there any doubt? Every people understood?
Yes, sir.
Yes, sir.
Now what I'm saying, suppose electron is revolving around that nucleus, so since it has speed, then it will have some wave nature, is not it? According to de Broglie hypothesis, right? Moving particle will have dual nature. So since it is revolving with some speed, it will have some wave nature, is not it? According to de Broglie hypothesis. Yes. So if you see that, if you draw a picture, so wave nature will be like this, and orbit is stable. So how much will be that perimeter of this orbit?
सर रिकॉर्डिंग स्टार्ट कर दीजिए.
Okay. So how much will be that radius of this orbit? Anyone? Sorry, perimeter. How much will be the perimeter of this orbit? 2 pi r, right? Perimeter will be how much? 2 pi r simply. Is not it?
Yes, sir.
And that 2 pi r should be equals to how much according to wave theory? Anyone? When it is revolving that circular orbit, that perimeter of this path will be 2 pi r. And since it has wave nature, so it will have some wavelength, right? According to wave theory, 2 pi r should be how much? 2 pi r equals to n into lambda, should be integer of lambda, according to wave theory. And that n value is like 1, 2, 3, so on. So perimeter of the path should be integer multiple of wavelength. Okay. Did you people get what I'm saying? So angular momentum, what you wrote, me into v into r, Now we'll substitute that expression for velocity and radius, and we'll see what will happen. So you got 2 pi r equals to n lambda. Also, according to de Broglie hypothesis, lambda will be how much? H by p, right? Is not it? Please respond me in my class.
Yes, sir. Yes, sir.
H by p, and you can write that H p is how much? Simply me into v, right? Is not it? So we will go from this first equation 2 pi r equals to n lambda, you will get r equals to n lambda by 2 pi, and from second equation lambda equals to h by mev. From here you will get v equals to h by me into lambda. Is not it? If you write from first equation, you have 2 pi r equals to n lambda. It means r is how much? R will be n lambda by 2 pi. Is not it? Every people agreed? From this equation, r will be n lambda by 2 pi, and from second equation, lambda equals to h by me into v. From this equation, you will get v will be h by me into lambda. Now, if you substitute that v and r in this equation, angular momentum equation, how much you will get? Anyone? Can you please calculate? Anyone? So you have that angular momentum L equals to how much? me into v into r. So if you keep me as it is, v is how much? H by me lambda, right? Then you have r. R is how much? N lambda by 2 pi. Now if you see, lambda will be cancelled, m will be cancelled. Simply how much will get? L will be how much? You have only n into h by 2 pi. So it means h by 2 pi is reduced Planck constant. So you can write n h cut. And n value can be 1, 2, 3, and so on. Every people understood that angular momentum
So
is
there's a lambda, right?
where?
N lambda by 2 pi.
Yeah. You see, no, v is how much? V will be from this expression h by me lambda, and from this expression r will be how much? N lambda by 2 pi. Then lambda will be cancelled. This lambda will be cancelled. Me will be cancelled. Only will have n into h by 2 pi. This lambda will be cancelled, so it will be simply n h cut. N value can run from 1, 2, 3, 4, and so on. Now you see the beauty of this equation. What is the beauty? Anyone? What is the beauty of this equation? What is the beauty of this equation? So you give that heading, right? That angular momentum is defined as this, and finally you are getting that angular momentum equals to n h cut, and n value can run 1, 2, 3. Only this value is allowed. It means the angular momentum of this orbiting electron is quantized in nature, because only these values are allowed, 1, 2, 3. So angular momentum can be h cut, 2h cut, 3h cut, so on. So angular momentum is quantized in nature. Second assumption is angular momentum is quantized in nature. Every people understood what I'm saying? The angular momentum of orbiting electron is quantized in nature. Only discrete values are allowed. That discrete values are h cat, 2h cat, 3h cat, so on. Right? According to classical mechanics, that angular momentum can take any value. This is continuous in nature. But when you are applying this wave theory, you are getting that angular momentum that is quantized in nature. Okay. Every people understood what I'm saying? Every people understood what I'm saying?
Yes, sir.
So
Yes, sir.
angular momentum is quantized in nature. Okay. That second heading will be. So you can basically from this equation, what you can write? So what you can write? ME V R should be equals to how much? N H cut, and that N value is 1, 2, 3. Now you see, you have positive fellow that is sitting at that nucleus, right? And electron is negatively charged, that is orbiting, is not it? If you see that structure of atom, you have positively charged at nucleus, that is proton, right? For the time being, what I am doing, only I am doing that calculation for hydrogen atoms. So for hydrogen atom, you will have proton that is at nucleus, and electron is revolving around it. Electron is negatively charged. Okay, so there will be Coulomb attraction, right? There will be Coulomb attraction, is not it? There will be Coulomb attraction. How much will be
Yes,
that
sir.
Coulomb force? How much will be that Coulomb force for a hydrogen atom? Anyone?
1 by 4 pi epsilon 0
Very good. 1 by 4 pi epsilon 0. Then,
q by r square.
so for hydrogen atom, you have proton at nucleus. That charge is how much? E, right? That charge for proton charge is how much? Like electron, right? And you have electron. So both charge Q1, Q2 by r square you used to write, right? But for these cases, both charge are E and E. So it should be E square by r square if that radius is r. Is not it? Every people understood what I'm saying? That Coulomb force or Coulomb attraction, that will be towards that nucleus. And that attraction is how much? 1 by 4 pi epsilon naught E square by r square. Is there any doubt in the class? Is there any doubt? Please respond me so that I can proceed. Because every people should understand that understood that class. Any doubt in the class? Is there any doubt? Is there any doubt in the class?
No, sir.
No, right?
No, sir.
Shall I proceed? Shall I proceed?
Yes, sir.
Okay. So you have that Coulomb force that is attracting towards center. Now, if any particle is rotating, you have one outward force. That force is name is anyone? When that particle is rotating, you have one outward force. That force is, that name is anyone? Centrifugal force, right? Centrifugal force. Anyone? So that outward force will be how much? That will be centrifugal force. Is not it? So whenever particle is rotating in a circular orbit, you will have one outward force. And that force is centrifugal force. How much will be that force? Suppose this one is F1, this one is F2. This should be me, mass of electron, into v square if its speed is v divided by r, right? Centrifugal force is this much, right? Me v square by r, is not it? Every people got what I am saying? Is there any doubt? So you see, this is your centrifugal force that is acting outwards, and you have Coulomb force that is acting towards nucleus. Since this orbit is stable, then these two forces should be balanced, is not it? According to first assumption that electron is orbiting in a stable orbit, since this orbit is stable, then that Coulomb attraction should be balanced by centrifugal force, is not it? Every people
Yes.
agree, every people agreed or not? Is there any doubt? So if you please respond me in my class, okay, so that I can proceed, I can understand now. So if you see, me v square by r should be equals to 1 by 4 pi epsilon naught into E square by r square. Now from this equation, if you substitute that v will be how much? So from this equation you will get v equals to nh cat by me into r. So simply me by r into nh cut divided by me into r square should be equals to 1 by 4 pi epsilon naught e square by r square. Is not it? So just what we have done from this expression, we have taken that v will be how much? NH cat by me into r, and we have substituted that v here. So me by r into v square will be NH cat by me into r whole square equals to 1 by 4 pi epsilon naught e square by r square. Now we can find that expression for r. Anyone? Expression for r will be how much? Anyone? Expression for r will be how much? So from this equation, if you solve it, you will get r equals to 4 pi epsilon naught n square h cat square divided by m e square. Sorry. So you see, the radius of the orbit is a function of n, and n is what? Principal quantum number that will teach you by Atul sir. So you see, radius of orbit is a function of n. That's why we have to write Rn, and that should be how much? 4 pi epsilon naught n square h cat square divided by me square. So this is the radius of nth orbit. Any doubt in the class? Any doubt? Any doubt in the class? You people understood this?
Yes, sir.
Yes, sir.
Everybody?
Yes, sir.
Please respond me. Okay. Okay. So very good. This is the expression. Now, so that value 4 pi epsilon naught h cat square divided by me square, that is equals to a naught. A naught is what? A naught is Bohr radius, and its value is how much? If you substitute that value 4 pi epsilon naught h cat, mass of electron, charge of electron, you will get a naught. A naught is the Bohr radius, and its value is how much? If you substitute, you will get 0.53 angstrom. Angstrom means how much meter? Angstrom means how much meter? Anyone?
10 to minus 10.
10 to the power minus 10, right? Very good. So now this expression will be radius of nth orbit of hydrogen atom will be n square a naught, and that n value is n will be 1, 2, 3 and so on. Now you see that orbit will be discrete in nature. So first orbit, that radius of first orbit will be how much? A naught, right? Because n will be 1. For second orbit, it will be, radius will be how much for second orbit? Anyone? Anyone in the class? The radius of second orbit will be how much? Or second Bohr orbit? How much? Anyone?
4 times the.
Very good. So for R1 will be how much? If you substitute n value 1, you will get simply a naught. This is the radius of first Bohr orbit. R2 will be, if you substitute 2 here, you will get 4 a naught. If you substitute 3, R3 will be how much? 9 a naught. Okay. Now you see that orbit are discrete in nature. Now if you draw that orbit, if you draw that electronic orbit, so this is your nucleus, this is your first orbit, this will be second orbit, this is your third orbit. So this radius from center, this radius will be how much? A naught. This will be how much? 4a0. Then this will be how much? 9a0. Okay, you see they are widely separated. Gap between the two orbits, successive orbits, are very large. Every people understood? Any doubt? Please respond me. Any doubt?
No, sir.
No, right? Are you enjoying class? Every people? Are you enjoying class?
Yes, sir.
किसी को लैंग्वेज में प्रॉब्लम हो रहा है? हिंदी में बोलूं? Please respond me. Okay. So this is your expression for radius. Now we'll find that expression for speed. So how we'll do that? So we know that formula ME VR, now it will be Rn equals to NH cut. Now ME, we'll calculate that V, we'll substitute that Rn. Rn is how much? Rn is how much? 4 pi epsilon naught n square h cat square divided by ME E square, that should be equals to NH cut. Is not it? Every people understood what I have done? Just I have substituted that expression for Rn that we have calculated, that is 4 pi epsilon naught n square h cat square divided by ME E square, and that should be equals to NH cut. Now can you solve? Can you find that expression for V? Anyone in the class? Anyone? So if you substitute, if you calculate it, how much you will get? E square divided by 4 pi epsilon naught n h cut. Okay, this will be cancelled. Now we see speed of electron for nth orbit is depends on that fellow small n. It means speed also is discrete in nature and it's a function of n, small n, that's why you have to write that subscript small n. Now let us define fine structure constant, that is denoted by alpha equals to E square divided by 4 pi h cat C. And that value, if you substitute that all electronic charge, Planck constant and speed of light, you will get 1 by 137. Okay. Now if you insert this fine structure constant alpha in this expression, so how much you will get? You have this C here, but you don't have C here. So you have to multiply and divide by
So
C.
what is alpha?
Alpha is fine structure constant and it is defined as E square by 4 pi h cat C. And that value, if you substitute E, h cut and C, you will get 1 divided by 137. So if you substitute, insert this alpha in this equation, you don't have C, so you have to multiply C and divide by C. And if you do this, you will get alpha C by N. Every people understood what I have done? Any doubt? Any doubt in the class? So just I have inserted that alpha in this expression, speed expression, you will get alpha C by N. Now can you, anybody calculate that speed of electron at first Bohr orbit? Anyone? Speed of electron at first Bohr orbit will be how much? Anyone? How much? So for first Bohr orbit, N is simply on, right? N is simply on. So for first Bohr orbit, N is simply on. So we'll get V on equals to alpha C. Alpha C, and you know that alpha is how much? 1 by 137. 1 by 137 into C. C is 3 into 10 to the power 8 meter per second. Now can you calculate Please calculate it and tell me how much will be that speed. How much will be that speed? Anyone? Please respond me. How much will be that speed?
0.021 into 10 raised to 8.
Very good. So if you calculate it, you will get 2.19 into 10 to the power 6 meter per second. Every people got that number? Every people got that? 2.19 into 10 to the power 6 meter per second. Can you imagine how much high speed it is? 10 to the power 6 meter per second. That much speed electron has in the first Bohr orbit. It's a very high speed. That's why that electron used to call relativistic particle. Okay? Every people got? Is there any doubt? So that speed will be 2.19 into 10 to the power 6 meter per second. For second Bohr orbit, n will be how much? N will be 2, right? So speed will be how much? V2 equals to, if you see that expression, alpha c by n. N will be how much? 2. Is not it? So you have got this alpha c value, that is how much? 2.19 into 10 to the power 6 meter per second divided by 2. Okay. How much will be that speed?
1.095.
1 point, very good. 1.09 into 10 to the power 6 meter per second. You can see that digit 10 to the power 6. It's a very high speed. Okay. That's why that electron in orbit is relativistic in nature. Please keep in mind. Okay. Is there any doubt or shall I proceed? Is there any doubt in the class? Is there any doubt in the class?
So,
No, right? Are you enjoying class? Every people enjoying class or any doubt? Okay. Now we'll calculate that energy, total energy that of that orbiting electron. So total energy will be how much? Total energy capital E should be equals to its kinetic energy plus its potential energy. Right? So kinetic energy will be how much? Kinetic energy will be simply half into mass of electron into Vn square, speed at nth orbit. Okay. So total energy of nth orbit will be how much? Half, sorry, kinetic energy plus potential energy, and kinetic energy will be how much? Simply half into me into Vn square. Now you know that Vn, right? So if you substitute it, me divided by 2, Vn was how much? E square divided by 4 pi epsilon naught, right? N h cut, right? And it's square. Is not it? So just I have substituted that expression for Vn. So it will be E square by 4 pi epsilon naught NH cat square. Okay. So if you solve it, you will get me e to the power 4 divided by 32 pi square n square epsilon naught square h cat square. Every people are getting? Can you please check? So it will be simply me e to the power 4 divided by 32 pi square n square h cat square epsilon naught square h cat square, and that is the kinetic energy of orbiting electron at nth orbit. Okay, any doubt? Shall I proceed? Shall I proceed?
Yes, sir.
Okay, so this is your kinetic energy. Okay, now how much will be the potential energy? Anyone? How much will be the potential energy? So potential energy of electron will be how much? Simply it will be your Coulombic potential, right? How much it will be? Anyone? How much will be the potential energy? It will be simply Coulombic potential, right? Minus c square divided by 4 pi epsilon naught into Rn, right? This is your potential energy, right? Potential energy expression is what? 1 by 4 pi epsilon naught Q1 Q2 by R, right? So you have that charge for Q1 and Q2 charge will be plus C and minus C, since that fellow sitting at that center is having plus charge and electron is orbiting, it has charge is minus. So Q1 Q2 will be simply minus C square divided by 4 pi epsilon naught, and that R is the radius of nth orbit. Now if you substitute that Rn, can you please substitute and check? So if we substitute it, E square divided by 4 pi epsilon naught, and Rn was how much? Anyone? Rn was how much? Rn was, yes,
4 pi epsilon naught n square h square by me square.
very good. 4 pi epsilon naught n square h cat square divided by me square. So me square will be in numerator, so it will be me square. So if you check it, you will get simply minus me minus me e to the power 4 divided by 16 pi square epsilon naught square n square h cat square. So potential energy of that electron will be how much? Minus me e to the power 4 divided by 16 pi square epsilon naught square n square h cat square. What is the meaning of minus? Anyone in the class? What is the meaning of minus? What is the meaning of minus? Anyone? So minus.
Sir, it is a bounded system.
Yeah, bounded system. You can say minus potential means attractive in nature, is not it? So you are correct. It's a bounded system. Or you can say if that potential is minus, so force will be derived from minus del V by del R. If you see force will be minus del V by del R. So it will come with negative sign. So it will be, if the force is negative, it means that force is attractive in nature. So you can say negative potential for this case implies that the force acting between these two fellow are attractive in nature. Did you get? Now, can you please derive that relation between kinetic energy and potential energy? Anyone? So we got that kinetic energy and potential energy. You see there is a relation. Anyone? Please respond me. There is a relation. There will be that relation between kinetic energy and potential energy.
Potential energy into minus 1 by 2 is kinetic energy.
Very good. So potential energy will be simply minus 1 by 2 into kinetic energy, right? So please keep in mind, you people have learned in planetary motion that kinetic energy should be minus twice of potential energy. So it is related to this also, because all electron is orbiting is like a planet, right? So this is the relation. Kinetic energy of that electron should be minus twice of potential energy. Now, how much will be that total energy? So total energy will be how much? Total energy E will be how much? It will be kinetic energy plus potential energy is how much? Potential energy will be, sorry, potential energy, sorry, extremely sorry. Potential energy will be twice of kinetic energy, right? Extremely sorry. This should be potential energy should be minus twice of kinetic energy. Please check it. Potential energy should be minus twice of kinetic energy because 1 by 16 in potential energy. But in kinetic energy, you have 1 by 32. So you have, if you multiply and divide in the potential energy by 2 factor, you will get potential energy will be minus twice of kinetic energy. So total energy capital E will be kinetic energy plus potential energy, and potential energy is nothing but minus twice of kinetic energy. So if you solve it, you will get total energy capital E is nothing but minus of kinetic energy. Okay. So total energy of this electron is minus of its kinetic energy. So if you substitute that kinetic energy expression, you will get energy, total energy is how much? So capital E will be how much? Minus ME e to the power 4 divided by 32 pi square n square epsilon naught square h cat square. So you see the total energy of that orbiting electron is a function of small n. Small n is what? It is a principal quantum number. So if you substitute that mass of electron, charge of electron, value of epsilon naught and Planck constant, you will simply get this value is minus 13.6 divided by n square in the unit of electron volt. So this is the energy expression of electron that is orbiting in hydrogen atom. Okay, so for nth orbit, that energy will be minus 13.6 by n square eV. What will be that ground state energy? Anyone? Ground state energy of electron? Can you please tell me that?
13.6.
Huh?
Yes, 13.6 electron.
Very good. For ground state will be, for ground state that n value should be equals to 1, right? So if you substitute that n value here, you will get ground state energy E1 equals to minus 13.6 eV. What about next first excited state? How much will be that energy?
So minus 3.4 electron volt.
Very good. So that for first excited state, remember this will be the first excited state. People always, student always used to make that mistake. First excited state means n is how much? 2. Please keep in mind. And for ground state n is 1. Okay, please keep in mind, because first excited state, whenever used to ask in the question, student used to write n is 1. That is not true. For first excited state, n will be 2. N equals to 2. So E2 will be how much? Minus 3.4, right? Okay. What about E3? Second excited state. Can anyone? What will be that E3? Anyone? Huh?
1.50.
1.50 minus, right? 1.50 is not it?
Sir.
Yes. So it is 1.50 minus 1.50. So you see that energy is negative. It means the system is bound, right? That electron is bound. It cannot freely move. Okay, that should orbit around that nucleus. So negative energy means the system is bound in nature. You can write it. Now if you draw that spectrum or draw the energy level of hydrogen atom, so you can see क्लास में सबको समझ में आ रहा है? एक एक करके बोलिए जरा, किसको समझ में नहीं आ रहा है? बोलिए जरा।
Yes, sir.
सबको समझ में आ रहा है?
Yes, sir.
हाँ,
Yes, sir.
अनुष्का, नीतू,
Yes, sir.
सबको समझ में आ रहा है?
Yes, sir.
ओके, कोई डाउट अभी तक जो हुआ है? किसी का कोई डाउट क्लास में? तो एनर्जी लेवल किस तरह की होंगे आपका, अगर इसका ड्रॉ करोगे एनर्जी लेवल ऑफ हाइड्रोजन एटम, or that energy level is basically electronic energy level. Electronic energy level of hydrogen atom. So suppose this is your ground state, E1. Then you will have, this is your first excited state, E2. This gap will be how much? This gap will be 10.2 electron volt. Now for third excited state, that gap will decrease, E3. If you see E3, if you make E2 minus E1, you will get this value 10.2 eV. Okay. Now if you do E3 minus E2, that will be less. How much it will be? Anyone? How much will be this value? This value will be how much? Anyone in the class? Please respond me. I'm saying the separation between first excited state and ground state for hydrogen atom will be very much high as compared to separation between E3 minus E2. And that separation, if you do, approximately you will get 1.9 electron volt. Okay. Any doubt? And so on. If you draw more line, that will be more close and separation will successively decrease. Okay. So once n equals to infinity, you will get continuous line level. Okay. किसी को कोई डाउट क्लास में? बोलिए जरा। सबको समझ में आ रहा है क्लास में? So okay. So today was that introductory class. Just we have learned that radius of electronic orbit is discrete in nature and they are widely separated. Also speed is discrete in nature and that speed is very high, that is of the order of 10⁶ meter per second. That's why that electron is treated as relativistic electron. And also we have learned that energy level of that electron is discrete in nature and they are separated, and the separation will start decreasing once you are going to higher state. Okay. Any doubt in the class? If no, then we can stop here. Today we will learn more. Okay. Sorry, tomorrow we will learn more. Today was that just introductory class. Okay. Most welcome.
Thank you, sir.
Most welcome. Okay, then I am leaving.
Thank you, sir.
Most welcome. So किसी को कोई डाउट हो तो बोलिए, नहीं तो मैं फिर लिख कर दूंगा. Is there any doubt? And please be frank in my class. Okay. If you ask many questions, I will be very happy in the class. Whatever doubt you have, okay, please ask me. Most welcome. Okay. Good night all. Tomorrow we'll learn more. Okay. Okay, I'm leaving. Okay. Bye all.